Welcome back again. So here we are going with another question. So it was like this. You have given a cantilever beam and there is a uniformly distributed load, on length L by 2 and this length is L by 2 and the total length is L. What we had to find was, just a minute. Sorry. Yeah. So what we had to find, what they asked was how will you design the beam? How will you design the beam? Then they ask counter question, what is SFD and BMD? Or for this case, then we had to explain whole BMD diagram to them. Explain all curves in BMD. ठीक है? And derive generalized equation for bending moment. Derive generalized equation for bending moment. ठीक है? So now we will proceed here. Now see. how we will how we will be designing the beam is, just we have to go with the standard procedure over here. First find SFD, first find BMD, find BMD, then think of those point which has a maximum shear force and think of those point which has maximum bending moment. So if the length of the beam is large enough, so shear force will not cause that much trouble, then the bending moment will be the major playing role, will have a major playing role. But if the length of the beam is not that large, so we have to think about the shear force also. Okay, and then we will design the diameter and all say length and breadth over there on that particular section appropriately. So this is how the beam can be designed. Then they asked the SFD and BMD that we have to draw over here. So I will change my pen color. Okay, now see. First I will draw the SFD. Okay. Now for SFD, and the variation is W. So now how will you go is like their point A, let's say this is B and this C. Now RA will be equals to W into L by 2. Okay. This is we have got. So we will put it here. This is upward. So W into L by 2. Then from this to this L by 2, it will be constant that there is no force acting in between. And now from here onwards, since it is UDL, then it will be the SFD will be SFD will be parabolic. So how you should draw here is we just have to think upon it. Okay. So oh, I'm sorry, not parabolic. Extremely sorry, guys. Oh, sorry, my blunder. Since this is a UDL, so here it will be a linear inclined line. So this is like this. Extremely sorry. A, B, and this point is C. So this was our SFD. This is WL by 2. Here is constant and 0 here, 0 here. Now let's go for BMD. BMD I will show you with different color. BMD. Yeah. Now see here. For calculation part, I can just draw without calculation, but we will. So draw with the calculation only. So adjust X here, or just find out, we will find out the MA here first. MA should be equals to simple W into L by 2. इंटू L/2 प्लस L/4। ठीक है ना। इसका जो इक्विवेलेंट है वो इसके सेंटर में एक्ट करेगा, W × L/2। Okay, so here it will be WL/2 into 2 times. Now this is so 3L/4. So this is 3WL square upon 8. Okay, but the sign direction will be anti-clockwise. Hmm. So anti-clockwise we taking negative. As per my convention, you may use the different conventions also, no problem. Like this, and then at L/2, if we see at x equals to L/2, m is equals to, see, W into L/2 into L/2. This is RA minus omega L square upon 8. So this is omega L square upon 4 minus 3 omega L square upon 8, which will give me this is still in minus. So minus omega L square upon 8. This will go like this. Yeah. Okay. This is point C. Here is C. This is B here. A. Now for C to B, it will move parabolically because the SFD is linear. Now here I will show you a short trick here. See how this is varying fast then slow. See here are large values and here are small. Okay, see, fast to slow, fast to slow. Then just a minute, I will just redraw it so you will understand it properly. Yeah. Now see the how there are two cases here. Okay. First case is this one and another is this one. Now how SFD was varying? Fast then slow, fast then slow. In similar fashion, BMD will vary. Then what will be the actual curve? Let's see. Actual curve will be something like this. Fast then slow. Now see, let's consider like this. Here the slope, because see, dm by dx is equals to v. So this is large, then slope is needed to be large. Okay. So fast then slow. It's satisfying over here. So it will be varying like this. Okay. So this is how BMD will be drawn here. Now the next question was explain all the curves in BMD. So this is how I explained you. You should explain it over there. So this was linear here, and then how it was varying parabolically. And you may derive a generalized expression also, since I'm going to derive it here. So let's see. So this was our beam here, like this. UVL, UDL, sorry. L/2, L/2. Okay, A, B, C. Now see. I'll use red color. Just a moment. Yeah. Now, see, we will take a section at X from A. So what will be the moment here? M at X will be RA into X minus MA, because RA into X is positive and this is anti-clockwise. Sorry, this is clockwise and MA will anti-clockwise. So this is positive, this is negative. Okay. So if we go and put the value over here, RA was, I think, RA was WL/2. So WL/2 X minus MA was, MA we had 3WL square by 8. 3, wait, WL/2 X minus 3WL square upon 8. This is limited up to L/2. Now if we want to add after C, we will go We may go either from point B also, but I'm just taking from A, so we are going with A. So mx will be, so this is now x distance. Okay. So WLx by 2 as it is, minus 3WL square by 8 as it is. Then here it will be minus again. So, yeah, yes. Minus or plus. I think I'm making some mistake over here. Mm, no, no, it's correct. Sorry, sorry, sir. It's correct only, na? Hmm. See what confusion I had was. सेफ्टी में अगर हम लोग देखें तो करेक्ट है, तो इसे आएगा, जीरो होगा, सही बात। वो वहां पे देखे तो बढ़ेगा। राइट। So yeah, let's continue here. I just unnecessarily confused myself. So everything is correct over here. I'm solving it correct. So this is now x is still here. Now what we will do is for the UDL wala part, if we go and see, this distance will be x minus L by 2. Okay. So if we write it over here, omega x minus L by 2 whole square upon 2. So this will be the bending moment variation. So I think we have answered all the questions that were asked. Yeah. So yes, with this we have completed our question. Thank you.